Good evening, students. Very good evening. I hope all of you are doing well. ಎಲ್ಲರೂ ಆರಾಮಾಗಿದ್ದೀರಾ, ಚೆನ್ನಾಗಿದ್ದೀರಾ ಅಂತ ಅನ್ಕೊಳ್ತಿದ್ದೀನಿ. ಎಕ್ಸಾಮ್ಸ್ ಇನ್ನೇನು ಹತ್ರ ಬರ್ತಿದೆ, ಪ್ರಾಕ್ಟಿಕಲ್ ಎಕ್ಸಾಮ್ಸ್ ಎಲ್ಲ ಶುರುವಾಗಿದೆ. ಸೊ ಇದ್ರ ಜೊತೆಗೆ ಅಲಾಂಗ್ ವಿತ್ ಯೋರ್ ಪ್ರಾಕ್ಟಿಕಲ್ ಎಕ್ಸಾಮ್ಸ್, ಐ ರಿಲಿ ಹೋಪ್ ದಟ್ ಯು ಆರ್ ಕಾನ್ಸಂಟ್ರೇಟಿಂಗ್ ಆನ್ ಯೋರ್ ಥಿಯರಿ examination as well, right? So previous live classes ಅಲ್ಲಿ ನಾವು ಒಂದಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವೆಶನ್ಸ್ ನ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. We have discussed about important questions related to inorganic and physical chemistry. ಅದಾದ್ಮೇಲೆ ಲಾಸ್ಟ್ ವೀಕ್ನ ಸೆಷನಲ್ಲಿ ನಾವು ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವೆಶನ್ಸ್, ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಆ್ಯಂಡ್ ಫ್ರೀಕ್ವೆಂಟ್ಲಿ ಆಸ್ಡ್ ಕ್ವೆಶನ್ಸ್ ಆಫ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಅನ್ನೋದನ್ನು ಕೂಡ ಲಾಸ್ಟ್ ವೀಕ್ನ ಲೈವ್ ಸೆಷನಲ್ಲಿ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀವಿ. ಸೊ ನಾವು ವಾಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡೂ ಇನ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಸೆಷನ್ ಅಂತ ಹೇಳಿದರೆ, ಬೇಸ್ಡ್ ಆನ್ all the previous year question papers and the previous year's knowledge, ಒಂದಷ್ಟು ರಿಪೀಟೆಡ್ ಅಥವಾ ಡೆಫಿನೆಟ್ ಕ್ವೆಶನ್ಸ್, ರಿಪೀಟೆಡ್ ಅನ್ನೋದಕ್ಕಿಂತ ಡೆಫಿನೆಟ್ ಕ್ವೆಶನ್ಸ್, ಫಿಕ್ಸ್ಡ್ ಕ್ವೆಶನ್ಸ್ ಅಂತ ಏನಿರುತ್ತೆ ಇನ್ಆರ್ಗ್ಯಾನಿಕ್ ಆ್ಯಂಡ್ ಫಿಸಿಕಲ್ ಕೆಮಿಸ್ಟ್ರಿನಲ್ಲಿ, ಅದರಲ್ಲಿ ಒಂದಷ್ಟು ಕ್ವೆಶನ್ಸನ್ನು ನಾವು ಈ ಲೈವ್ ಸೆಷನ್ಗೆ ಚೂಸ್ ಮಾಡಿಕೊಂಡು I am going to explain you and I'm going to tell you few simple tricks to remember and to write the answers, the pattern of writing answers for these important or fixed definite questions that will surely appear in your examination. At least the topic nimge pattern gottadre, even if the compound is changed slightly, you will be able to answer for sure. So that is an assurance from my side. So ಇವತ್ತಿನ live class ಅಲ್ಲಿ ನಾವು we are going to discuss about the definite questions, some of the definite questions that will appear in the part C as well as part D section of your chemistry paper, okay, final examination paper. ಅದರಲ್ಲಿ ಮೇನ್ ಆಗಿ ಇವತ್ತಿನ ಲೈವ್ ಸೆಷನ್ ಅಲ್ಲಿ ನಾವು ಪಾರ್ಟ್ ಸಿ ನಲ್ಲಿ, ಅಂದ್ರೆ 3 ಮಾರ್ಕರ್ಸ್ ಏನಿರುತ್ತಲ್ಲ, ಪಾರ್ಟ್ ಸಿ ಇಸ್ ಟೋಟ್ಲಿ ಫ್ರಮ್ ಇನ್ಆರ್ಗ್ಯಾನಿಕ್ ಪಾರ್ಟ್. ಸೊ ಇನ್ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಪಾರ್ಟ್ ಇಂದ ನಿಮಗೆ ಯಾವೆಲ್ಲ ರೀತಿಯಾದಂತಹ ಡೆಫಿನೆಟ್ ಕ್ವೆಶನ್ಸ್ ಬರುತ್ತೆ, ಅದರಲ್ಲಿ ಒಂದಷ್ಟು ಡೆಫಿನೆಟ್ ಕ್ವೆಶನ್ಸ್ ಅನ್ನ ನಾನು ಇವತ್ತಿನ ಲೈವ್ ಸೆಷನ್ಗೆ ಚೂಸ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. ಆ್ಯಂಡ್ ದೆನ್ ಐ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಟೀಚಿಂಗ್ ಯು ಆಸ್ ಟು ಹೌ ಯು ಕ್ಯಾನ್ ಆನ್ಸರ್, ಹೇಗೆ ಆನ್ಸರ್ ಬರಿಬೋದು ಈ ಎಲ್ಲ ಕ್ವೆಶನ್ಸ್ಗೆ, ಹೌ ಕ್ಯಾನ್ ಯು ಆನ್ಸರ್ ದೀಸ್ ಕ್ವೆಶನ್ಸ್ ಆ್ಯಂಡ್ ವಾಟ್ ಪ್ಯಾಟರ್ನ್ ಆರ್ ಯು ಸಪೋಸ್ ಟು ರೈಟ್ ದಿ ಆನ್ಸರ್, ಆ್ಯಂಡ್ ಅಟ್ ದಿ ಸೇಮ್ ಟೈಮ್ ಯಾವ ಥರ ಎಷ್ಟು ಸ್ಟೆಪ್ಸ್ ಬೇಕಾಗುತ್ತೆ, ಎಷ್ಟು ನೆಸೆಸಿಟಿ ಇದೆ ಅಥವಾ ಎಷ್ಟು ನೆಸೆಸರಿ ಇದೆ ಅಷ್ಟು ಮಾತ್ರ ಬರೆಯೋದನ್ನು ನೀವು ಕೆಮಿಸ್ಟ್ರಿನಲ್ಲಿ ಕಲ್ತ್ಕೋಬೇಕು. ಸೊ ಆಲ್ ದಿಸ್ ವಿ ವಿಲ್ ಡಿಸ್ಕಸ್ ಇನ್ ಟುಡೇಸ್ ಕ್ಲಾಸ್. ವೆಲ್ಕಮ್ to today's live session on teacher app, and teacher, we are always with you, okay? So on the basis of the first question that we're going to discuss is related to valence bond theory of coordination compounds. So the first question that you can see here on the PPT is chosen from the chapter coordination compounds. Coordination compounds in the ನಾನು ಆಲ್ರೆಡಿ ನಿಮಗೆ ತಿಳಿಸಿರೋ ಹಾಗೆ ಒಂದು 2-3 ರೀತಿಯಾದಂತಹ ಕ್ವೆಶನ್ಸ್, ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವೆಶನ್ ಪ್ಯಾಟರ್ನ್ ಇದೆ. ಅದರಲ್ಲಿ ಒಂದು ಫಿಕ್ಸ್ಡ್ ಕ್ವೆಶನ್ ಅಂತ ಇದ್ರೆ ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ಸ್ ಚಾಪ್ಟರ್ ಇಂದ, ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ದಿಸ್ ವೇಲೆನ್ಸ್ ಬಾಂಡ್ ಥಿಯರಿ. ಸೊ ವೇಲೆನ್ಸ್ ಬಾಂಡ್ ಥಿಯರಿನಲ್ಲಿ, ಓಕೆ, ಸೊ ಯೂಸಿಂಗ್ ವೇಲೆನ್ಸ್ ಬಾಂಡ್ ಥಿಯರಿ ದಟ್ ಯು ವುಡ್ ಹ್ಯಾವ್ ಸ್ಟಡಿಡ್ ಇನ್ ದ ಫಸ್ಟ್ ಇಯರ್ನಲ್ಲಿ ನೀವು ಬೇಸಿಕ್ ವೇಲೆನ್ಸ್ ಬಾಂಡ್ ಥಿಯರಿ ಅಂದರೆ ಏನು ಅಂತ ಓದಿದ್ದೀರಾ, ಅದನ್ನು ಬಳಸ್ಕೊಂಡು, ಈ ವೇಲೆನ್ಸ್ ಬಾಂಡ್ ಥಿಯರಿ ನೀವು ಫಸ್ಟ್ PU ನಲ್ಲಿ ಓದಿರೋದನ್ನು ಬಳಸ್ಕೊಂಡು ನಾವು ಹೇಗೆ ಯಾವುದೋ ಒಂದು ಕೊಟ್ಟಿರುವಂತಹ ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್, ಇಫ್ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ಅ ಪರ್ಟಿಕ್ಯುಲರ್ ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್, ಸೊ ಹೌ ಡು ವಿ ಫೈಂಡ್ ಇಟ್ಸ್ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಆ್ಯಂಡ್ ಜಾಮೆಟ್ರಿ ಆ್ಯಂಡ್ ಇಟ್ಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿ ಅನ್ನೋದನ್ನು ತಿಳ್ಕೊಳ್ಳೋಣ. ಓಕೆ, ಸೊ ದ ಫಸ್ಟ್ ಕಂಪೌಂಡ್ ದಟ್ ಐ ಹ್ಯಾವ್ ಚೋಸನ್ ಹಿಯರ್, ನಿಮ್ಮ NCERT ಟೆಕ್ಸ್ಟ್ ಬುಕ್ನಲ್ಲಿ 4 ಎಕ್ಸಾಂಪಲ್ಸ್ ಅನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ ವೇಲೆನ್ಸ್ ಬಾಂಡ್ ಥಿಯರಿ ರಿಲೇಟೆಡ್. ಸೊ ಅಮಾಂಗ್ ದಿ 4 ಎಕ್ಸಾಂಪಲ್ಸ್ ಎನಿ ಒನ್ ಇಸ್ ಅ ಶೋರ್ ಕ್ವೆಶನ್. ಸೊ ಇದಂತೂ ಕನ್ಫರ್ಮ್. ನೀವೇನು ಮಾಡಬಹುದು ಅಂತ ಹೇಳಿದ್ರೆ, ನಾನು ಇವತ್ತಿನ ಕ್ಲಾಸಲ್ಲಿ ನಿಮಗೆ ಪ್ಯಾಟರ್ನ್ ಗೊತ್ತಾಗಲಿ ಅಂತ ಐ ಹ್ಯಾವ್ ಚೋಸನ್ 2 ಸ್ಲೈಟ್ಲಿ ಡಿಫ್ರೆಂಟ್ ಪ್ಯಾಟರ್ನ್ಸ್ ಆಫ್ VBT ರಿಲೇಟೆಡ್ ಕ್ವೆಶನ್. ಓಕೆ, ಸೊ VBT ಅಪ್ಲಿಕೇಶನ್ ಕ್ವೆಶನ್ಸ್ ಏನಿದೆ, 2 ಕಂಪೌಂಡ್ಸ್ ಅನ್ನು ನಾನು ಚೂಸ್ ಮಾಡಿದ್ದೀನಿ. ಒಂದು ಕೋಬಾಲ್ಟ್ ಕಂಪೌಂಡ್, ಇನ್ನೊಂದು ನಿಕಲ್ ಕಂಪೌಂಡ್. ಆನ್ ದ ಸೇಮ್ ಲೈನ್ಸ್ ಇದೇ ಪ್ಯಾಟರ್ನ್ ಅಲ್ಲಿ ನೀವು ಮತ್ತೊಂದು 2 ಕಂಪೌಂಡ್ಸ್ ಅನ್ನ ಇವತ್ತೇ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ರೆ, ಸೊ ಔಟ್ ಆಫ್ 4 ಟೋಟಲಿ ಗಿವನ್ ಇನ್ ಯೋರ್ NCERT ಯಾವುದಾದ್ರೂ ಒಂದು short question. So out of 4 NCERT VBT application questions, okay, so out of 4 VBT application questions given in your NCERT, any one is a short question. So please make a note of this. So we are going to start with the first example that has been given here. Athwa ನಾವು ತಗೊಂಡಿರೋ example, it is tetracyanonickelate compound, right? So tetracyano ಅಥವಾ tetracyanide compound ಏನಿದೆ, complex ಏನಿದೆ, so we are going to try and we're going to find out the hybridization, geometry and magnetic property of this given compound. So ಹಾಗಾಗಿ how do we find all these things? Main ಆಗಿ ನಿಮಗೆ 3 mark question, okay? So it is a short 3 mark question. 3 marks ಅಲ್ಲಿ ಹೇಗೆ ಮಾರ್ಕ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, for finding the hybridization 1 mark will be given, for finding the correct geometry 1 mark will be allotted, and finding the magnetic property 1 mark. So ಹಾಗೆ ಈ ರೀತಿಯಲ್ಲಿ 3 ಮಾರ್ಕ್ಸ್ ಅನ್ನ ನಿಮಗೆ ಡಿವೈಡ್ ಮಾಡಿರ್ತಾರೆ. ವಾಟ್ ಇಸ್ ಸ್ಟೆಪ್ 1? ಇದರಲ್ಲಿ ಸ್ಟೆಪ್ 1 ಏನು ಅಂತ ಹೇಳಿದ್ರೆ, ಯು ಆರ್ ಸಪೋಸ್ ಟು ಫೈಂಡ್ ದಿ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಆಫ್ ನಿಕಲ್ ಇನ್ -2 ಸ್ಟೇಟ್. ಓಕೆ, ಸೊ -2 ಸ್ಟೇಟ್ ಅಲ್ಲಿ ನಿಕಲ್ದು ನೀವು ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಅನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಅದಕ್ಕೂ ಮುಂಚೆ ಯು ಶುಡ್ ನೋ ದಿ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ಕನ್ಫಿಗರೇಷನ್ ಆಫ್ ನಿಕಲ್. ವಾಟ್ ಇಸ್ ದಿ ಔಟರ್ಮೋಸ್ಟ್ ಕನ್ಫಿಗರೇಷನ್ ಆಫ್ ನಿಕಲ್ ಇನ್ ದಿ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್? ಎಸ್, ರೈಟ್. ಇಲ್ಲಿ ಒಂದು ಸಣ್ಣ ಟ್ರಿಕ್ ಇದೆ. ಏನು ಅಂತ ಹೇಳಿದ್ರೆ, ನಿಮಗೆ ಈ 3D ಸೀರೀಸ್ನ ಎಲಿಮೆಂಟ್ಸ್ನ ಅಟಾಮಿಕ್ ನಂಬರ್ ನೋಡಿದ ತಕ್ಷಣ ಯು ವಿಲ್ ಬಿ ಏಬಲ್ ಟು ಫೈಂಡ್ ಔಟ್ ದಿ ನಂಬರ್ ಆಫ್ ವೇಲೆನ್ಸ್ ಡಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಹೇಗೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಿಕಲ್ atomic number of nickel is 28. Therefore, the outer electronic configuration of nickel is going to be 3d8 4s2. Okay, so number of electrons in the d subshell will be equal to the last digit of its atomic number. So except for copper and chromium in 3D series, you can apply this trick for all the other elements. So adhe tara nickel 28 irodrinda 8 is the last digit in the atomic number of nickel. Therefore, in the outermost valence configuration of nickel also there will be, in the d subshell there will be 8 electron. Therefore, the outermost configuration is 3d8 4s2. This is in the ground state, right? But otherwise, so that's in the ground state. But ನೀವು oxidation state ನಲ್ಲಿ find out ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, therefore, so nickel in -2 oxidation state. ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋ ಪ್ರಕಾರ what is the common oxidation state that you are trying to tell you here? It is -2 oxidation state, right? So andre you have to find out. I'm sorry. So ಇಲ್ಲಿ -2 ಅಂತ ಹೇಳಿದ್ರೆ it is for the complete complex ನದ್ದು -2 oxidation state. So therefore, let's try to find out the oxidation state of nickel in this particular given example. Let's try to do that quickly. Right, so quick agi try to find out the oxidation state of nickel. So what is the oxidation state? How do you do that? Illi ನಾವು ತಗೊಂಡಿರುವಂತಹ ಕಾಂಪ್ಲೆಕ್ಸ್ ನಲ್ಲಿ ನಾನು ಇಲ್ಲೇ ರಫ್ ಆಗಿ ಬರಿತಾ ಹೋಗ್ತೇನೆ. So illi in this you are supposed to find the oxidation state of nickel. So let's take it as x plus the charge of each cyanide group is -1 into how many cyanide groups are present? 4 cyanido groups. So therefore -1 into 4, which is equal to, what is the charge on the overall charge of the complex? It is -2. Therefore x is equal to, this becomes -4. Adana ನೀವು right hand side ತಗೊಂಡ್ರೆ +4 -2. Therefore x is equal to +2, right? Therefore in this particular compound, the oxidation state of nickel is +2. Therefore, find the oxidation state, write the electronic configuration of nickel in +2. So 3d8 4s2 nalli +2 ant helidre, the positivity is increasing. That means there is negativity removal of negativity. Aa thara ನೀವು ನೆನಪಿಟ್ಕೋಬಹುದು. +2 oxidation state ಅಂದ್ರೆ removal of 2 electrons, right? So if you remove 2 electrons from the s subshell, ಉಳಿದಿರೋದು ಎಷ್ಟು? We are left with 3d8 electrons. So this is the first step, right? This is the most important step. First step, very very important. Adadmele nickel na oxidation state +2 oxidation state alli in Ni2+ state, the ground state electronic configuration is 3d8. Very important. Next step alli, second step, step 2 nalli navu ಏನು ಮಾಡ್ತಾ ಬರ್ತೀವಿ ಅಂತ ಹೇಳಿದ್ರೆ, okay, so we will have to write the orbital diagram for this particular outer electronic configuration in the oxidation state that you have found out. So in the +2 state, so nickel in the +2 state, 3d8 electrons andre first orbital diagram na draw ಮಾಡ್ಕೊಳ್ಳಿ ನೀವು, right? So if this is 3d subshell, ಇಲ್ಲಿ 8 electrons ಅನ್ನು ನಾವು fill ಮಾಡಬೇಕು, and according to your first year knowledge, right, how do you fill up the electrons? This is how you fill up the electrons. Always fill up single electrons first, correct? 3 4 5 6 7 and 8. We are done. So we are left, we have 3 pairs of electrons plus 2 single electrons here. This is how you write the orbital diagram for nickel. But next ಏನಾಗುತ್ತೆ? Nickel in the plus 2 oxidation state is present and cyanide group. Okay, so 4Cn minus ligands approach the central metal atom, which is the CMI, central metal ion yaudu. The CMI here is nothing but Ni2 plus, nickel is the central metal ion. So when 4 cyanidoligands approach the central metal ion, what's going to happen? 4 cyanidoligands ant helidre nimage ಏನು ನೆನಪಾಗಬೇಕು? ಪ್ರತಿಯೊಂದು each Cn minus, okay, each Cn minus would donate 1 pair of electron, right? And since cyanido group is a strong ligand, that's also very, very important. Since it's a strong ligand, okay, so what will it do? Strong ligands pair up the electron. This is something you have to remember. Strong ligands tend to pair up the electrons, whereas weak ligands, weak field ligands, okay, these are strong field ligands. Cyanide group is a strong field ligand and therefore it will pair up the electron. It will pair up the electrons. This is something you have to remember. This is important. Whereas weak field ligands do not pair up the electrons. So next step alli ಏನು ಆಗ್ತಿದೆ? When the cyanide group approaches, right? When the cyanide group approaches the nickel central metal ion, again ಆಗ್ತಿದೆ, already nickel nalli there were 8 electrons present. Let's redraw the orbital diagram, right? So this was the 3D subshell. Illi already ನಾವು ನೋಡಿರೋ ಪ್ರಕಾರ ಹೇಗೆ ಏನಾಗಿತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ, we had filled up 8 electrons. First step ಅಲ್ಲಿ fill ಮಾಡಿದ್ವಿ, but in the last two boxes pair ಆಗಿರಲಿಲ್ಲ, right? So ಇಲ್ಲಿ single electrons ಇತ್ತು, but once the cyanide group approaches the central metal ion, these electrons tend to get paired up. Okay, so electrons pair ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಆಗ ಏನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, in the first 3 boxes the electron arrangement would remain the same. 3 pairs of electrons ಹಾಗೆ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. In the 4th box, okay, ಇಲ್ಲಿ single electrons 2 ಇತ್ತಲ್ಲ, ಇದೇನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, these 2 single electrons get paired up and this is how we write. So 4 boxes get filled up. ಅದಾಯ್ತಾ? ಅದಾದ್ಮೇಲೆ there are 4 pairs of electrons which are being donated by the cyanide group, right? So there are 4 pairs of electrons that are being donated by the cyanide group and you have to accommodate ಮಾಡಬೇಕು. ಈ cyanide group ಕೊಟ್ಟಿರುವಂತಹ electrons ಅನ್ನ ನಾವು accommodate ಮಾಡ್ತಾ ಬರಬೇಕು. So how do we do that? For that you require vacant orbitals. Vacant orbitals ಎಲ್ಲಿದೆ? You know that after the 3D orbital there is definitely presence of 4s orbital and 4s orbital can accommodate how many electrons? Only 1 pair of electron ಅಥವಾ 2 electrons. So ಹಾಗಾಗಿ there is requirement of few more next orbitals, right? So 3D ಆಮೇಲೆ 4s ಆದ್ಮೇಲೆ 4p orbital ಬರುತ್ತೆ. So according to Aufbau principle. So ಈಗ we have one box, the second one, third and the fourth one. ಈ 4 boxes ಅಂತ ಹೇಳ್ಬಾರ್ದು, they are called the orbitals, right? So in the 4 orbitals, one pair of electron donated by the ligand will be accommodated. ನಾನು ಇಲ್ಲಿ ಸೆಪರೇಟ್ ಆಗಿ ಒಂದು ಬಾಕ್ಸ್ ಅನ್ನು ಹಾಕ್ತೀನಿ. Okay, I'll better choose a different color so that you can make out the difference here. Okay, so blue color ಅಲ್ಲಿ ನಾನು ಈಗ ಏನು ಮಾರ್ಕ್ ಮಾಡ್ತಿದ್ದೀನಿ. So look at this. ಇಲ್ಲಿಂದ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ these 4 orbitals, right? We have accommodated 4 pairs of electrons donated by the ligand in these 4 orbitals. So, ಈ 4 orbitals ಯಾವ್ಯಾವುದು? D1, ಒಂದೇ ಒಂದು D orbital ಇದೆ. ಹಾಗಾಗಿ D, ಇಲ್ಲಿ ಒಂದೇ ಒಂದು S orbital ಇದೆ. So, DS, ಇಲ್ಲಿ 2 P orbital ಇರೋದ್ರಿಂದ DSP2. And please make a note of this, students. So, the hybridization, okay, hybridization ಅಂದ್ರೆ ಏನು? Receiving of electrons for the formation of bonds and overlapping of the orbitals. So due to this, DSP2 hybridization is being taking place between the ligand and between the central metal ion, right? So ಹಾಗಾಗಿ ಒಂದು D subshell, ಒಂದು S subshell and 2 P subshell. So the hybridization is DSP2. And from your previous knowledge, right, you know that, you have studied that whenever the compound, whenever the compound possesses dsp2 hybridization, then we already have learnt that the geometry, okay, so the geometry is going to be square planar. For dsp2 hybridized orbitals, the geometry is going to be square planar. So nimigilli 1 mark bartide for finding the hybridization. From the hybridization, for predicting the geometry, you will be getting 1 more mark. So dsp2 hybridized orbitals ant helidre the geometry is going to be square planar. And next ಅವ್ರು ಏನು ಕೇಳಿದ್ದಾರೆ ನಿಮಗೆ ಕ್ವೆಶ್ಚನ್ ಅಲ್ಲಿ ಅವರು ಕೇಳಿರೋ ಪ್ರಕಾರ they have asked you to find the magnetic property. Magnetic property ಹೇಗೆ find out ಮಾಡ್ತೀರಾ? Look at the last step of VBT that you have written here. Last step nalli, okay, so in the second step, as you can see, all the electrons have been paired up. Illi single electrons yavdu illa. So hagagi, again from your previous knowledge, okay, so based on that, how do you predict the magnetic property? If all the electrons are paired up, if there are no single electrons, then we say that the compound is diamagnetic. So you can make a note of this, for which you will get 1 mark. So altogether you will be getting a total of 3 marks. So this is how it is divided. So let me just quickly recall. Let us just quickly recall what we have done. First step ಅಲ್ಲಿ ನೀವೇನ್ ಮಾಡಬೇಕು ಮಕ್ಕಳೇ ಅಂತ ಹೇಳಿದ್ರೆ, ನೀವು ನಿಕ್ಕಲ್ನ ಇಲ್ಲಿ ಕೊಟ್ಟಿರುವಂತಹ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಅಯಾನ್ ಯಾವುದು ಅದರದ್ದು ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ. ಸೊ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ ಆದ್ಮೇಲೆ ರೈಟ್ ಡೌನ್ ಇಟ್ಸ್ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕನ್ಫಿಗರೇಷನ್ ಫಸ್ಟ್. ಅದಾದ್ಮೇಲೆ ರೈಟ್ ಡೌನ್ ಇಟ್ಸ್ ಆಕ್ಸಿಡೇಷನ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಔಟರ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕನ್ಫಿಗರೇಷನ್ ಇನ್ ದಿ ಆಕ್ಸಿಡೈಸ್ ಸ್ಟೇಟ್. ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್ ಇಂದ ಆ ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್ ಅನ್ನ ರೆಫರೆನ್ಸ್ ಆಗಿ ಇಟ್ಕೊಂಡು ರೈಟ್ ಡೌನ್ ಇಟ್ಸ್ ಔಟರ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕನ್ಫಿಗರೇಷನ್ ಇನ್ ದಿ ಆಕ್ಸಿಡೈಸ್ ಸ್ಟೇಟ್. ದೆನ್ ಟ್ರೈ ಟು ರೈಟ್ ದಿ ಆರ್ಬಿಟಲ್ ಡಯಾಗ್ರಾಮ್ ಫಾರ್ ದಿ ಸೇಮ್ ಆಕ್ಸಿಡೈಸ್ಡ್ outer electronic configuration, right? So once you write the orbital diagram, the next step is to identify the ligand. Ligand ಅನ್ನ ಐಡೆಂಟಿಫೈ ಮಾಡಿ ನಂತರ ನೀವು ಅದು ವೀಕ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ ಅಥವಾ ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ ಅನ್ನೋದನ್ನ ನೀವು ಚೆಕ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. So whether it's a strong field ligand or weak field ligand, try to find out that. After that, once you find out, strong field ligands tend to pair up the electrons, whereas weak field ligands they tend to they don't pair up the electron. This is something you're supposed to remember. So since cyanide group Cn minus is a strong pair ligand, strong field ligand, it pairs up the electron. So illiruanta single electrons ಏನಾಗುತ್ತೆ ಅದು pair ಆಗ್ತಾ ಹೋಗುತ್ತೆ, right? So pair ಆಗ್ತಾ ಹೋದ್ಮೇಲೆ ನಂತರ you will use the vacant orbitals. ಇರುವಂತಹ vacant orbitals ನಲ್ಲಿ the pairs of electrons which are being donated by the ligands are supposed to be accommodated. Since each cyanide group is going to donate 1 pair of electron, 4 cyanide groups are going to donate 4 pairs of electron which are going to be accommodated in the vacant orbital. So, in vacant orbitals nalli neevu 4 pairs of electrons anna accommodate ಮಾಡಿದಾಗ ನೀವು ಎಲ್ಲೆಲ್ಲಿ ಯಾವ್ಯಾವ ಆರ್ಬಿಟಲ್ ನಲ್ಲಿ ಆ 4 ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರ್ಸ್ ಡೊನೇಟೆಡ್ ಬೈ ಲಿಗ್ಯಾಂಡ್ಸ್ ಅವುಗಳನ್ನ ನೀವು ಅಕಾಮಡೇಟ್ ಮಾಡಿರ್ತೀರೋ that itself is going to be the hybridization. So I hope you have understood, and by knowing the hybridization you can predict the geometry, and by looking at the number of paired or unpaired electron pattern you can find out whether the compound is diamagnetic or whether it is paramagnetic. So this is how you will find the VBT, you will find the hybridization, geometry and magnetic property of the given compound using VBT. ಇದೇ ತರ ಕ್ವಿಕ್ ಆಗಿ ನಾವು ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಅನ್ನ ತಗೊಳ್ಳೋಣ, and here we will try to find out, okay, on the same basis, on the same lines, quickly we will try to write down or find out the hybridization of the given compound using VBT, right? So step 1 ಅಲ್ಲಿ ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋ ಕಂಪೌಂಡ್ ಯಾವುದು? ಇದು ಕೊಟ್ಟಿರೋ ಕಂಪೌಂಡ್. ಇದರಲ್ಲಿ in the given compound, first in the step 1 try to find out the oxidation state of cobalt, right? So illi let's first write down the ground state electronic configuration of cobalt. The atomic number of cobalt is 27. ನಾನು ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ಹೇಳಿದ ಹಾಗೆ the last digit itself is going to give you or the last digit of the atomic number of 3D series. Only for 3D series this is applicable, this trick is applicable. The last digit of the atomic number of the 3D series is exactly equal to the number of electrons in the D subshell. So hagagi what is the electronic configuration of cobalt? It is 3D 7 4s 2. Okay, so that is the electronic configuration of cobalt, 3d7 4s2. But now let's find out the oxidation state of cobalt in this given complex. ನಾನು ಇಲ್ಲೇ ಕ್ವಿಕ್ ಆಗಿ ಬರೀತೀನಿ. cobalt ನ oxidation state ಅನ್ನ x ಅಂತ ತಗೊಂಡು ನಂತರ you know that amine group is the ammonia, actually ammonia molecule, but it's called as amine group in coordination compounds. I hope you know all that. IUPAC nomenclature ಅಲ್ಲಿ amine group ಅಂತ ಕರಿತೀವಿ ಇದನ್ನ in coordination compounds. So amine group is a neutral ligand, right? So therefore the charge is going to be 0 into 6 amine groups. 0 iddaga it doesn't matter, which is equal to the charge, correct? So plus 3. So cobalt is in plus 3 state in this particular given example. So quickly write down the oxidation state, I mean electronic configuration of cobalt in its oxidation state. Plus 3 ant helidre removal of 3 electrons, 2 electrons from here, 1 electron from here. Therefore now the outer electronic configuration of cobalt in the oxidation state is 3d6. The step is very important. Ee step alli ನೀವು ತಪ್ಪು ಮಾಡಿದ್ರೆ ಮುಂದೆ ಎಲ್ಲ steps wrong ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So be very very careful. Next, step 2, right? In this step 2 you will have to write down the orbital diagram for cobalt in the plus 3 oxidation state. Write down the orbital diagram quick agi. Let's write down the orbital diagram. Yes, so this is 3d orbital. Matte 3d aadmele by default there will be 4s orbital, there will be 4p orbital, correct alva? And there will also be a 4d orbital. Idella irutte, requirement iddaga matra navu use ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ, correct? Right. So now 3d orbital nalli there are 6 electrons here. So how do I fill up the 6 electrons? Always single electrons first, right? Adadmele the 6th electron will be placed here. Next, since NH3 amine group is a strong field ligand, okay, since it's a strong field ligand, nanu ಏನು ಹೇಳಿದೆ, strong field ligands tend to pair up the electrons get paired, correct? So since NH3 is a strong field ligand, the electrons of cobalt get paired. Therefore, CO in the plus 3 state, once the NH3 approaches it, hege baritivi ನಾವು ಅದನ್ನ ಮತ್ತೆ rewrite the entire thing. This is 3d energy level in the paired up state. So ಇಲ್ಲಿರುವಂತ single electrons ಅನ್ನ ನೀವು pair up ಮಾಡಿ ಬರಿಬೇಕಾಗುತ್ತೆ. This is how you write it. ಅದಾದ್ಮೇಲೆ of course there is 4s, 4p orbital, and of course 4d orbital, right? Next, in the next step, step 3, okay, so the ligand is now approaching, the ligand has already approached and it is trying to form a bond with the central metal ion cobalt. ಆಗ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ನೋಡಿ, each amine group, okay, so ನಾನು ಇಲ್ಲಿ ಬರಿತೀನಿ note ಅಂತ. So each amine group will donate one pair of electron, right? One pair of electron. So ಹಾಗಾಗಿ ಇಲ್ಲಿ ಎಷ್ಟು amine groups ಇದೆ? NH3 6 groups. So therefore 6 pairs of electrons will be donated, which should be accommodated in these vacant orbitals. ಅದನ್ನ ನಾವು ಮಾಡ್ತಾ ಹೋಗೋಣ. First write down the electrons corresponding to central metal ion. Already nickel alli 6 electrons ide in the paired state now due to the approach of ligands. Adashtuna barkolana. Adadmele there is 4s vacant orbital, there is 4p vacant orbital, right? And then there is also 4d vacant orbital. Now I'll take a different color so that you can differentiate between the things. Now we ga ಏನು ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳಿದ್ರೆ, with a different color I will try to fill the electrons corresponding to the ligand. Ligand ಇಂದ ಇಲ್ಲಿ 6 pairs of electrons ಬರ್ತಾ ಇದೆ, ಅದನ್ನ accommodate ಮಾಡಬೇಕು. First pair, second, third, fourth and fifth. So ನಾನು ಇಲ್ಲೊಂದು ಬೌಂಡ್ರಿಯನ್ನು ಹಾಕ್ತೀನಿ. 1, 2, 3, 4, 5 and 6. Yeah, 6th pair of electrons. So I'll put a boundary here. ಈಗ ನನಗೆ ಹೇಳಿ how do we predict the hybridization? ಇಲ್ಲಿ d orbital ಎಷ್ಟು ಯೂಸ್ ಆಗಿದೆ? d2. There are 2 d orbitals which are participating in bond formation. Therefore d2. ಮತ್ತೆ ಎಷ್ಟು s orbital? Only 1 s orbital, s. ಆಮೇಲೆ ಎಷ್ಟು p orbital? 3p orbital. Therefore the hybridization, okay, hybridization is d2 sp3. This is how you find out the hybridization. And since it is D2sp3 hybridization, the geometry, you know that whether it is sp3d2 or d2sp3, of course the geometry is going to be octahedral. 6 bonds form agodrinda octahedral geometry, very important. Next, let me know something about the magnetic nature. Magnetic nature anna nodi last step alli, do we have any unpaired electrons? Illa, all the electrons are in the paired state, therefore it is a diamagnetic complex. Okay, therefore it is a diamagnetic complex, right? So suppose if this was not in the paired state, okay, yavado ondastu electrons paired state alli irlilla anta helidre, what would that mean? Can anybody tell me? Yes, it would mean that, it would clearly mean that it is a paramagnetic compound. But illi paired state alli irodrinda it is a diamagnetic compound, right? So ಯಾವುದೇ ಒಂದು electron ಕೂಡ ಒಂದು electron pair ಅಲ್ಲಿ ಇಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ, we have single electrons, even in one single orbital it should be considered as a paramagnetic complex. But now it is a diamagnetic complex since all the electrons are in the paired state. So 1 mark for your magnetic property, 1 mark for the hybridization, and 1 mark for the geometry. So this is how you predict the hybridization, geometry, and the magnetic property of the given compound. Okay, so this is how you actually predict it. I hope you have understood the concept. ಇದೇ ರೀತಿಯಲ್ಲಿ ನಿಮಗೆ ಯಾವುದೇ ಒಂದು ಕಂಪೌಂಡ್ ಕೊಟ್ಟರು ಕೂಡ ನೀವು ಅದರ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಜಾಮೆಟ್ರಿನ ಇದೇ ರೀತಿಯಲ್ಲಿ in the same pattern you should be in a position to find out. Okay, so this was all about predicting the geometry, hybridization and magnetic property using valence bond theory, VBT. Next we will move on to the second important question of the chapter. So VBT related question is a fixed question. ಅದು ಬಿಟ್ಟು ಇನ್ನೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವೆಶ್ಚನ್ ಇದೆ, ಫಿಕ್ಸ್ಡ್ ಅಂತ ನಾನು ಹೇಳೋದಿಲ್ಲ, ಆದರೆ ತುಂಬ ಫ್ರೀಕ್ವೆಂಟ್ ಆಗಿ ಕೇಳಿರುವಂಥ ಕ್ವೆಶ್ಚನ್ ಅಥವಾ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವೆಶ್ಚನ್ ಇದೆ, which is called as the crystal field splitting, right? Most commonly called as CFT theory ಅಂತ ಹೇಳ್ತೀವಿ. Just like VBT, CFT is again a very very important theory. So CFT nalli, okay, what are we going to find out? We are going to talk about the splitting pattern. So why is the splitting of the d orbital happening? How is it happening? How is it different for octahedral as well as tetrahedral? There are two compounds, octahedral compounds and tetrahedral compounds. Idu hege aagtade annodanna ನಾವು ಕ್ವಿಕ್ ಆಗಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಹೋಗೋಣ. So here first let's take the example of an octahedral compound, octahedral complex, right? So crystal field splitting ಹೇಗೆ ಆಗ್ತಿದೆ octahedral complex ನಲ್ಲಿ ಅಂತ ಹೇಳಿದ್ರೆ, first initially look at this diagram, right? Let me explain all this to you with the help of the diagram itself. So initially ಇಲ್ಲಿ 5 bars ಅನ್ನ ನೀವು ನೋಡ್ತಾ ಇದ್ದೀರಾ, 5 bars correspond to, each bar corresponds to each orbital, okay, separate orbital of the d subshell. ಆ ಥರ ನೀವು ನೆನ್ಪಿಟ್ಕೋಬಹುದು. So it is dxy, dx txz, dyz, dx square minus y square and dz square. So 5 d orbitals are first placed here. ನಿಮಗೆ ಗೊತ್ತಿರೋ ಹಾಗೆ d orbitals ನಲ್ಲಿ within the d subshell there can be 5 orbitals, right? So dxy, dyz, dxz, dx square minus y square and dz square. So idu initially these orbitals are called degenerate orbitals, correct? The first PU nalli ಓದಿದ್ದೀರಾ. What are degenerate orbitals? Degenerate orbitals are those orbitals having or possessing same energy. So suppose there are a set of orbitals possessing same energy, ಒಂದೇ ತರದ ಎನರ್ಜಿಯನ್ನ possess ಮಾಡಿದ್ರೆ, okay, so we can call those set of orbitals to be degenerate orbitals. So initially, since all the suborbitals of the d subshell are possessing same energy, they're all called degenerate orbital. But this is in the normal condition. But when ligand approaches the central metal atom, okay, but when the ligand approaches central metal ion, splitting of orbital takes place. Okay, so splitting of orbital takes place, which itself can be called as crystal field splitting. Crystal field splitting, CFS, and the energy required for this is called crystal field splitting energy. So, in the natural condition, d subshell and all the orbitals of the d subshell are of course degenerate. They all have same energy. But when the ligand approaches the central metal ion, splitting of the orbital, because ligand is going to approach the particular ligand and it will influence the central metal ion. So, ligand is going to influence the central metal ion, and as a result of that there will be splitting of orbitals taking place. Splitting of orbitals hege agutte, yav pattern alli agutte annode illi important. So the splitting pattern is different for octahedral compounds or octahedral complexes when compared to or in comparison to the tetrahedral complexes. So this is very important. Illi look at the octahedral splitting, and you also know that first PU nalli neevu matte innondana odidira neevu. ಅದೇನು ಅಂತ ಹೇಳಿದರೆ among the d orbitals, the three sets of d orbital, dxy, dyz and dzx, these three have their lobes present in between the axis, whereas dx square minus y square and dz square have their lobes present along the axis. Nan quick agi just one example anna kodtini just to recall the theory which you already studied. Nimge idu basics already gottirbeku. Quick agi I'll just tell you what I'm actually talking about. What do I mean by that? So if at all you consider dxy orbital here, okay, so if this is the dxy orbital and if this is x-axis, if this is y-axis. So illi for dxy orbital the lobes will be present in between the axis. So if this is x-axis and if this is y-axis, illi lobes are present in between the axis, whereas for dx square minus y square, okay, so hegirutte the lobes will be present along the axis, not in between the axis. The lobes will be present along. This is the major difference. So illi enagutte octahedral complexes nalli, okay, in the case of octahedral compounds this is very important. Neeven bardilla andru ee statement anna barilebeku. So for octahedral complexes, okay, so this is very important. For octahedral complexes, ligand approaches the central metal ion along the axis. This is very important. Mark ಮಾಡ್ಕೊಳ್ಳಿ, along the axis. So therefore ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ along the axis ಈ ತರ ligand approach ಮಾಡೋದ್ರಿಂದ L ಅಂತ ಹೇಳಿದ್ರೆ ligand, okay, so ligand will approach the central metal ion along the axis. So ಈ ತರ ಇಲ್ಲಿ ligand approach ಮಾಡೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ, the orbitals whose lobes are present along the axis experience greater repulsion. ಯಾಕೆ ligands ಅಲ್ಲಿ ಕೂಡ electrons ಇರುತ್ತೆ, free electrons irutte, and even these lobes of the orbitals contain electrons. So electrons and electrons, when they come closer, they repel each other because both have same charge. Yes, no, both are negatively charged. Therefore, both of them, you know that negative, the similar charge particles repel each other. So the greater repulsion will be experienced by those orbitals having their lobes present along the axis. So illi dx square minus y square matte dz square orbitals ge their lobes are present along the axis, and therefore since the ligand approaches the central metal ion along the axis, this dx square minus y square and dz square orbitals, these two orbitals experience greater repulsion. Initially idu ground state alli in the normal condition, okay. So normal conditionally all the d orbitals are in their degenerate state. Once the ligand approaches the central metal ion, the degeneracy completely, okay, is lifted. Degeneracy is lifted complete agi. All the 5 orbitals go to higher energy, lift agutte. Adadmele splitting takes place based on the attachment or approaching of ligand towards the central metal ion. So since ligands approach the central metal ion along the axis for octahedral compounds, dx square minus y square and dz square experience greater repulsion, okay, these two experience greater repulsion, as a result of which their energy is lifted. They move to the higher energy level. If they move to the higher energy level, what about the other 3 orbitals? Of course, they will be comparatively in the lower energy. And this itself is called crystal field splitting. This is how the degeneracy of the d orbitals is broken. and as a result, a part of the d orbital moves to the higher energy level and the other part of the d orbitals moves to the lower energy level. And here, especially for octahedral complexes, the dx square minus y square and dz square orbitals move to higher energy since they experience greater repulsion. This completely is called as crystal field splitting, crystal field theory ಅಂತ ಕರಿತೀವಿ. CFT ಅಂದ್ರೆ crystal field theory, which explains the crystal field splitting pattern, and the energy required for this itself is called crystal field splitting energy. So this is all about crystal field splitting in octahedral compounds. So based on the same thing, ನಿಮಗೆ ಈ theory ಅರ್ಥ ಆಗಿದ್ರೆ, let's be a little more quick with the next theory because it's exactly the same. Okay, so initial everything remains the same, but only the last splitting pattern slight agi change agutte. So let's have a look at the tetrahedral splitting pattern very quickly. So this is the crystal field splitting pattern in tetrahedral compound. So initially enagutte, like I've told you, all the d orbitals initially, okay, so initially all the d orbitals are degenerate. That means they all have same energy and they are all present in the ground state. Next step alli enagutte, as ligand approaches, okay, as ligand approaches the d orbital, complete d orbital, the degeneracy or the total energy, complete energy of all the orbitals, the degeneracy is lifted, right? The degeneracy is lifted. This is what happens ಇಲ್ಲಿ. ನಾನು ಇದನ್ನ step 1 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಇದನ್ನ step 2 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ. So initially all the d orbitals are in the ground state. Once the ligand approaches the d orbital, the entire degeneracy of the d orbitals is lifted to a higher energy level. ಅದಾದ ನಂತರ ಏನಾಗುತ್ತೆ? In step 3, what happens? The approaching of ligand makes the difference. And here for tetrahedral complexes, very important. For tetrahedral complexes, okay, so for tetrahedral complexes, the ligand approaches, ನೀವು ಏನು ಬರ್ದಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರು ಕೂಡ ಈ ಥಿಯರಿನಲ್ಲಿ ಎಕ್ಸಾಮಲ್ಲಿ ಕೇಳಿದಾಗ, diagram is very very important. You should definitely write the diagram. Along with the diagram, you're supposed to write this particular sentence, this last sentence, okay? So for tetrahedral complexes, the ligand approaches the central metal ion. Central metal ion alline d orbitals irutte. Ligand approaches the central metal ion in between the axis. So this is very very important. ಹಾಗಾದ್ರೆ ಏನಾಗುತ್ತೆ? Therefore all the orbitals, right, all the orbitals having their lobes, oriented in between the axis, okay, oriented in between the axis, experience greater repulsion. ನೀವು ಈ ಥರ್ಡ್ ಪಾಯಿಂಟ್ನ ನೀಟಾಗಿ ಬರೆದ್ರೆ ಸಾಕು, ಅಷ್ಟು ಬರೆದ್ರೂ ಕೂಡ ನೀವು ಸಾಕಾಗುತ್ತೆ ಎಕ್ಸಾಮಿಗೆ. So this experiences greater repulsion. And now tell me, which of the d orbitals experience greater repulsion? Yes, the lobes of the d orbitals which have their lobes oriented in between the axis are dxy, right, dxy, dyz and dzx. So these three orbitals experience greater repulsion since the ligand approaches them in the same direction. So they experience greater repulsion and the degeneracy is broken here at this stage, and the energy of dxy, dyz and dzx gets lifted. It gets raised due to experience of greater repulsion. And ಈ ಮೂರು orbitals ಜಾಸ್ತಿ ರಿಪಲ್ಷನ್ ಅನ್ನು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡಿ ಹೈಯರ್ ಆರ್ಬಿಟಲ್ಗೆ ಅಂದರೆ ಹೈಯರ್ ಎನರ್ಜಿ ಲೆವೆಲ್ಗೆ ಮೂವ್ ಆದರೆ ವಾಟ್ ಶುಡ್ ಹ್ಯಾಪನ್ ಟು ದಿ ಅದರ್ ಟು ಆರ್ಬಿಟಲ್ಸ್? ಆಫ್ ಕೋರ್ಸ್ ದಿ ಅದರ್ ಟು ಆರ್ಬಿಟಲ್ಸ್ ವಿಲ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಕಂಪ್ಯಾರಿಟಿವ್ಲಿ ಲೆಸರ್ ರಿಪಲ್ಷನ್ and they will of course settle down in a lower energy condition. This is how the energy degeneracy, same energy of the d orbital is broken, and there will be differences in the energy level. The one is the higher energy and the lower energy splitting pattern is observed. So initially andre basically ನೀವು ನೆನಪಿಟ್ಕೋಬೇಕಾಗಿರೋದು ಏನು ಅಂತ ಹೇಳಿದ್ರೆ, for tetrahedral complexes the central metal ion andre the ligand approaches the central metal ion in between the axis. This is the most important point. Whereas for octahedral complexes, the ligand approaches the central metal ion along the axis. This is what you're supposed to remember, based on which we will be able to draw the diagram here. So diagram anna ನೀವು ಇಲ್ಲಿ ನೋಡ್ತಾ ಇದ್ದೀರಾ, right? ಆಮೇಲೆ ಇಲ್ಲಿ how do we write the energy? This total energy, complete energy is called the crystal field splitting energy. ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ CFSC, crystal field splitting energy ಅಂತ ನಾವು ಅದನ್ನ ಕರಿತೀವಿ ಇದರಲ್ಲಿ. Okay, so how do you write the individual energies for both the energy states? Since 2 orbitals out of 3, okay, have moved to the lower energy levels, so ashtu illi missing irodrinda illi this energy is written as 2/5. Total 5 orbitals, adralli 3 have experienced greater repulsion and they have moved to the higher energy, whereas 2 orbitals have moved to the lower energy. So 2/5 is remaining. 2/5 orbital delta T. Delta T andre it is a subscript used for tetrahedral complexes. Next, lower energy state anna nodi. 2 orbitals have occupied lower energy, remaining ಎಷ್ಟು 3 orbitals remaining. So 3 out of 5 are remaining. So 3/5 delta T. Delta T corresponds to tetrahedral complexes. Okay, so this is what you can see in the lower energy state. ಇದೇ ರೀತಿಯಲ್ಲಿ ನಾವು octahedral ಗೆ ಕೂಡ ಬರೆದಿದ್ದೀವಿ. Octahedral ಅಲ್ಲಿ 2 orbitals out of 5 have experienced higher energy state, right? So therefore remaining ಎಷ್ಟು 3. 3 out of 5 should move to the ground state. So delta O. What is delta O here? Octahedral compound ಆಗಿರೋದ್ರಿಂದ the subscript that we use is delta O. ಅದೇ ರೀತಿಯಲ್ಲಿ lower energy state ಅನ್ನ ನೀವು ನೋಡಿ 2/5 delta O ಅಂತ ಬರೆದಿದ್ದೀವಿ. 2/5 delta O ಅಂತ ಹೇಳಿದ್ರೆ among 5 orbitals 2 orbitals have experienced greater repulsion. ಅಂದ್ರೆ 2 have experienced greater repulsion. Therefore, the remaining 2/5 delta O. O corresponds to octahedral compound. This is how you write the general energy for each of the higher as well as the lower energy pattern. So this is all about crystal field splitting in octahedral as well as tetrahedral complexes. Main agi ನೀವು ಇಲ್ಲಿ ನೆನಪಿಟ್ಕೋಬೇಕಾಗಿರೋದು ಏನು ಅಂತ ಹೇಳಿದ್ರೆ the direction of approaching of ligand. ಅದರಲ್ಲಿ ನೀವು ಮಿಸ್ಟೇಕ್ ಮಾಡಿದ್ರೆ the complete pattern would go wrong. So please remember the direction of approach of ligand. So this is crystal field splitting that we can observe in the case of octahedral and tetrahedral compounds. So in today's class, so we discussed about the valence bond theory application related question. ನಾನು ನಿಮ್ಗೆ already ಹೇಳಿದ ಹಾಗೆ there are 4 questions given in your textbook related to VBT, valence bond theory application. Make sure that you're thorough with all these questions, right? ಅದಾದ್ಮೇಲೆ there are only 2 crystal field splitting pattern, octahedral ಮತ್ತೆ tetrahedral splitting pattern. So ಇದೆರಡನ್ನ ನೀವು ನೋಡ್ಕೊಂಡ್ರೆ ನೀಟಾಗಿ ಕಲ್ತ್ಕೊಂಡ್ರೆ this will be very very helpful for your exam. And once again let me repeat, ನಿಮ್ಮ VBT application questions ಇದೆಯಲ್ಲ, they are extremely important and they are like the fixed question, definite questions that will appear in your exam. So this is all about today's live session. I really hope that today's information was really helpful, and please make sure that you practice the other NCERT examples given in your textbook ಅಲ್ಲಿ ಇರುವಂತ ಎಲ್ಲ VBT application questions 4 ಇದೆ. ನಾವು ಎರಡನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡಿದೀವಿ. Please make sure to practice today itself, right? So this was all about today's live session. All the best for your practical exams and all the very best for your theory exams also. So in the next class we will take up the remaining questions. Okay, so ಇವತ್ತು 4 important questions ಅನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡಿದೀವಿ, ಟಾಪಿಕ್ಸ್ ಅನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡಿದೀವಿ. ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ನಾವು we will take up the important questions from the P block elements chapter. From the chapter P block elements, we will try to discuss all the important questions related to chapter P block elements, right? Thank you so much, students. Thank you so much for attending the class. I hope today's session was informative. Yes, so we shall meet next week. Thank you.